Okay, here we are. Taking care of the size, distance, and motion, and you're reviewing it regularly to keep it in your brain so your brain doesn't dump it. We've got the missions. We have the context, and we know about Apollo missions. We know there are a lot of missions that led up to that. And there are a lot of missions since then, by the way, but none of them have had people on them because our robots have gotten better, but we do want to bring people back. So lots of missions. Watch that direct from the moon. And so on. The high definition is really, really spectacular. And a lot of missions from other countries too, recently here. And now we'd like to say, well, where did moon come from? Where did it come from? So before 1987, there are three ideas. Now let's look at our best idea, and you can see where we're going to go after that. Moon layers, surface features. Might have to rely on the book for that. We'll see if I get that video done. And here we are, moon's origin. So you can pause and take a video on that. So here were these ideas. The idea here was maybe it came from a different part of our solar system. It was just a chunk flying by, and we know that happened because that period of heavy bombardment of Earth got slammed, the moon got slammed. So maybe something was just flying by and it got caught in Earth's gravity. And so you wonder that. Because some other moons they were captured moons, captured chunks. However, if that's true, as it turns out, and we'll talk about this in chapter 7, the composition, the type of material changes, and the mix of material changes as we go farther out from sun. So if it came from another region, say out by Mars, between Mars and Jupiter, and we'd expect it to be different enough to tell that it was from a different place. You're not from here. What do you find when you analyze that stuff? For 15 years, the stuff brought back? Well, you would expect moon to be very different if it came from a different region, but it's not. It is different, but it's also similar. And so studying that says, no, not the case. Rule that out. Some are captured. We'll see them. Chapter 8. What else? You can pause this. As it turns out, most moons are formed in co-creation. And co-creation means that, as Earth is here orbiting the sun, and we'll talk about this again, we're leading right into chapter 7, you know how I do it. How did the whole solar system form at the same time, 4.6 billion years ago, as Earth clumped up, and right next to it, you know how close the moon is to Earth, maybe just, it chunked up into two things, one bigger, one smaller. And if it's made out of the same stuff, then it's basically the same stuff. And you go up and bring that and you analyze it and you go, nope. It is similar, but it's different enough to say it didn't come from this neighborhood. It's different enough. You'd expect, in this case, you'd expect it to be very different. In this case, you'd expect it to be very much the same as Earth. And when you analyze it to crazy detail, it just doesn't fit. It just doesn't fit. And then the other one is, well, Earth was spinning faster. Maybe when it was really hot, it didn't have these continents. It wasn't all formed like this with water and everything. In the early formation, we're talking about very early on, in that 4.6 billion years, right? Very early on, somewhere in the 0.1 billion years era or something. As it's spinning really fast, maybe a chunk just flew off. In that case, you'd expect it to be just like Earth, part of Earth, called fission or breaking off. Earth was spinning faster, so maybe a piece broke off. We would expect it to be same as Earth, but nope. And so here we are, and we've got to cross all of this off and just say no. Wow, and here's a great example of science. you know, people thought this, people thought that. But if the evidence tells you otherwise, you go, wow, I really thought that was the case. And right now, what stands up with the evidence, the strongest and very strong, lots of good evidence, who knows what we'll find in the future, is this. I'll even do a demonstration for you. Analyzing all that moon stuff, about 850 pounds worth of stuff brought back, and analyzing it for 15 years, right, since 1972, 69 through 72, right? And testing and better equipment, you know, you rule those out and you go, you know what, I think I have a collision ejection. Something from another region of the solar system, so different. I mean, not entirely, but enough different you can tell the difference. The size of Mars, which is about 1/2 the diameter of Earth. This, half this way, half this way, half that way, half the diameter of Earth. Something came in, and it didn't get caught. It's like playing baseball and getting to catch it with your mitt and catch it with your face. It got slammed. Broke into pieces. Some of Earth joined, spun around, gradually came back together. And so here's how it went. What's this, right? Oh yeah, pretty fancy. Huh? So it starts out like this, half as wide, ends up like this, 1/4 as wide. Stuff flies off, etc. So let's put that down. And 1/4 the diameter of Earth. When did it happen? Very early. You can check if you want, but very early in the solar system. So no landforms or anything like that. I mean, that's a big smack, right? Hey, wait a minute. What did I just do? Could it be? I mean, we need evidence. We check it, but could it be? Bunch of pieces fly off, come back together. What did I get? What could I have gotten from that big smack? I don't want to call it a big bang because, you know, that's the universe, but okay. Tilt. And where there's tilt, there are seasons. Interesting. Thank you, Moon, for smacking us in the face. Maybe you gave us our seasons. And so did we go to Moon? Well, we brought back a whole bunch of stuff. We analyzed it. It changed our whole perspective on things. And this is the idea that stands as the best understanding of where Moon came from. All right, cool. That's it for now.